Welcome back to Maths with Mrs. J. We're now ready to put together a lot of the techniques that we've learnt about factorisation. Let's have a look at the list of things that we need to look for. This is what I've been harping on about the whole time. Common factor first. Not only, in fact, should you always take out the common factor first, but you should keep looking as you go through your stages of working to see if there are any more common factors you can bring out. Always, when you get to your answer at the end, or what you think is your answer, check every bracket to make sure whether there is or isn't a common factor that can be brought right out the front. So keep checking for common factors. Keep checking for difference of two squares, that sort of thing. For it to be fully factorised, every bracket must be fully factorised. Okay, once you've taken out any common factors, we're going to look for special things like a perfect square or a difference of two squares. Particularly if we've got four terms, we're going to be on the lookout for pairing options. Maybe 2 and 2, taking a common factor out, and then you might get a bracket the same that you can bring out the front. And then obviously any quadratic expressions, you know how to deal with those now, both when there's a 1 in front of your x squared term and when there's another number other than 1. I've also got a few challenges here. I'm actually going to put a little stamp on some of these because these are kind of cool. They're a little bit different, a little bit more interesting than the norm. And I do want to go through those with you. It's about being able to recognise a pattern, and that's important. Okay, let's get started. So having a look at our first one here, 3x squared minus 75. Well, our very first thing we need to look for is a common factor. Yes, we can take out a 3 as a common factor. Now we look at our bracket and we can see we've got a difference of two squares. So we leave our 3 there, we don't forget about it. And this now is going to factorise as x plus 5, x minus 5, or x minus 5, x plus 5. This next one, it might be an idea to consider some pairing because we've got 4 terms. There's definitely no common factor we can take out of everything, but let's see how we go when we're pairing here. We can take an x squared out of the first 2 terms. Oh, and look, well, that's really just one lot of x plus 5, isn't it? So that's quite nice and easy. So your x plus 5 is your common factor and x squared plus 1. Can we do anything with x squared plus 1? No, we can't, because it is the sum of 2 squares, not the difference of 2 squares. It is certainly not x plus 1 all squared. Please bear that in mind. Remember, an x plus 1 all squared has a middle term of 2x. So if you ever have the sum of 2 squares in the real number system, there's nothing else you can do. Okay, let's have a look at this next one here. We've got something squared minus something squared. Okay, we've got a difference of 2 squares, haven't we? So let's put in some big brackets perhaps, and we're going to have our a minus b plus our 3b, because this is really 3b all squared, our a minus b minus our 3b. Now technically I didn't have to put those inner brackets there because there's really just a 1 multiplying that, and there's nothing out the front of here, so we're all good there anyway. A plus 3b minus b is a plus 2b, just collecting our like terms there. A minus b minus 3 more b's is a minus 4b. It doesn't hurt to put in extra brackets just to be sure. Certainly if you're taking something away here, if this was a bracketed expression, you would definitely want to put in your extra brackets just to be sure. Okay, number 4. Let's have a look at this. Well, it's a quadratic expression But let's check before we launch into that. Let's have a look and see if there's a common factor we can take out first. Well, there is. We can take out a 3 and we end up with that. Now we've just got our situation where we've got a 1 in front of our squared term. So we should be able to go straight to our 2 brackets here. And what we're looking for are 2 numbers that multiply to give negative 12 and add to give negative 4. So one's going to be positive, one's going to be negative, and they're going to be 4 apart. So negative 6 and positive 2 will work. Okay, next one. Right, there's no common factor we can take out of everything. It is a quadratic expression. There's not a 1 in front of the x squared. So what we're doing here are the ones where we're trying to work out 2 numbers that multiply to give AC. So we want them to multiply to give negative 60. And we want them to add to give B, which is negative 4. So here's where we're thinking about our factors of 60. In this case, we're going to have one of them is going to be negative and one's going to be positive, and they're going to be 4 apart. If we think about 10 and 6, and then because we want negative 4, if we do negative 10 and positive 6, that will work, won't it? They will multiply to give negative 60, and they will certainly add to give negative 4. So let's do that. We're splitting up our middle term into its 2 components there. Now we're in a situation a little bit like this, where we're going to take out a common factor out of each of these pairings, and we've rigged it so that we get this same bracket, and this bracket will come out the front, and we're left with 5x plus 6 in our other bracket. Now these 3 challenge questions, I want you to have a look at them and see if you can recognise some sort of pattern happening. Have a look at this one first of all. We've got x plus 3 squared minus 12 lots of x plus 3 plus 20. Let's get out the old colours. X plus 3 squared minus 12 lots of x plus 3 plus 20. If we let A be x plus 3, then really what we've got is a squared minus 12a plus 20. We do have a quadratic expression. How would I factorise that? Well, I'd go straight to my brackets. I'd go to my a minus 10, a minus 2 would work. They need to multiply to give positive 20 and add to give negative 12. So we get that. Well, but our a was just our x plus 3. So we can come back here now. I would show that working, by the way. Come back here and we're going to have x plus 3 minus 10, x plus 3 minus 2, just tidying that up. X plus 3 minus 10 is x minus 7. X plus 3 minus 2 is x plus 1. Now the next one is a similar situation, except obviously we've got a slightly more complicated slightly more complicated bracketed expression, but it's still the same idea. So if we let a be 2x plus 1, what we've actually got is a squared plus 7a plus 12. That's a nice easy quadratic to factorise. We're going to get a plus 3, a plus 4. So again, let's just go back and say, well, a was actually our 2x plus 1, so we're going to get 2x plus 1 plus 3, 2x plus 1 plus 4. And again, it's not really necessary to have 2 lots of brackets there because there's really just 1 outside of this one. Collecting like terms, 2x plus 1 plus 3 is 2x plus 4. 2x plus 1 plus 4 is 2x plus 5. Now have a look here. Just be careful. Look at this bracket here. We have a common factor in there. We need to bring that out. We can't leave our answer like that. So we need to then say, well, that's 2 times x plus 2 times our 2x plus 5. Okay, keep looking at your brackets all the time to see if there are any further common factors you can take out. All right, last one. Let's have a look at this expression here. X to the 4th minus 5x squared plus 4. Well, x to the 4th is really x squared squared, isn't it? So if I call a x squared, what I've really got here is a squared minus 5a plus 4. X squared squared minus 5x squared plus 4. So we've got a quadratic, but in x squared, in essence. So we're going to get our a minus 4, a minus 1. So coming back here, we're going to get x squared minus 4, x squared minus 1. Now, do we just stop there because we've already done enough and we're feeling a bit tired? No. We look at our brackets and we see what else can we do there. We've got a difference of 2 squares and we've got another difference of 2 squares. So we're actually going to get x plus 2, x minus 2, x plus 1, x minus 1. So this one actually, you get 4 brackets as your answer.